Hi everyone, welcome back to my video about programming in Go. This video is the first part of the topic number 3, methods and interfaces. And in this video, we will cover methods. The materials for topic 3 that I use in my videos include the sections about methods and interfaces from a tour of Go, which is a Go document, and chapter 6 and chapter 7 from the Donovan's and Kennigan's textbook. If you are taking this course with me at IU South Bend, please read those materials for more details about topics 3 of methods and interfaces. Now let's get started with methods. If you have learned Java, you may know that methods are member functions of a class. Unlike Java, Go does not have classes. It only has struct, which has member data but no member functions. However, you can define methods on types. In Golang, a method is just a function with a special receiver argument. The receiver appears in its own argument list between the keyword funct and the function name or method name. As an example, suppose we have defined a vertex struct in this program. Then we define function apps with a receiver named v of type vertex. So apps is a method on type vertex. Here apps is written as a regular function with no change in functionality. It takes no argument after its name and returns a float64 value which equals the square root of the sum of squares of the fields x and y in vertex v. After defining methods apps, we can call it on any vertex instance using the dot operator. For example, in the main function of the same program, we declare vertex instance v1 and then call methods apps on v1 by writing v1.apps followed by the regular argument list of the function apps. In the previous slide, we have seen an example of a method on a struct type. You can, however, declare a method on non-struct types as well. But there's a restriction. That is, the receiver's type must be defined in the same package as the method. So that means that you cannot declare a method with a receiver of a building type such as int or float64. But we can get away from this restriction by defining a new type that is the same as a building type such as float64, and we define that in the same package where the method on the new type will be defined. For example, here we defined myFloat as a new type, but it's the same as float64. And then we define methods apps on myFloat type. In the body of the method apps, it returns a float64 value that is converted from the negative f or the value f, where f is the receiver. And so negative f or f has the value of type myFloat, which is the same as float64, so it can be converted to float64. And in the main function, we can declare a variable f of type myFloat which is converted from a float64 value, and then you can call the method apps on that value of my float type. If a method is declared on a type T, then we say T implements that method. So in this example, we say that my float implements the method apps. You can also declare methods with pointer receivers. This means that the receiver type has the literal syntax star T for some non-pointer type T. That means that the type T itself cannot be a pointer type such as star, int, or pointer to int. So for example, given the vertex struct, the scale method here is defined on the pointer to vertex. So the receiver V in this example is a pointer receiver. So V is a pointer to vertex, and you can use the dot methods to access the fields of the vertex instance pointed to by V, as in any pointer to a struct type. The receivers whose types are not pointer types are called value receivers. There's an important difference between pointer receivers and value receivers. That is, methods with pointer receivers can modify the value to which the receiver points to. But methods with value receivers do not change the value of the calling receivers. For example, here we define two methods on the struct typed vertex. The first method, scale1, is defined with a value receiver, while the second method, scale2, is with a pointer receiver. Other than that, both methods work the same way. That is, they both take a float64 value f as argument and multiply its field x and y of the receiver with the argument f. To see the effect of the difference between these two methods, we declare a vertex instance named v in the main function. Vertex v has value 3 for the field x and value 4 for the field y. Then we call method scale1 on vertex v with argument 10. This call will multiply 10 to v.x and v.y, but when we display the value of v.x and v.y after the method call, the values are the same as before the call. They are 3 and 4 instead of 30 and 40. The reason is, with a value receiver, the scale1 method operates on a copy of the original vertex value. So method scale1 does not change the value of vertex v in the main function. Now we call scale2 method also on vertex v and with the same argument 10. Note that Go interprets the call v.scale2 of 10 as ampersand of v dot ampersand of v dot scale2 of 10. Since method scale2 has a pointer receiver, then we display these values of v.x and v.y after the call and see that those values have changed from 3 and 4 to 30 and 40. The scale2 method must have a pointer receiver to change the vertex value declared in the main function. Since methods often need to modify their receiver, pointer receivers are more common than value receivers. Now that we have learned what a function is and what a method is, let's compare between methods and functions. Remember that a method is just a function with a receiver argument. So every method is a function, but not every function is a method. However, any method can be rewritten as a function without a receiver. For example, here methods apps and scale2 are rewritten as functions without receiver arguments by simply making the original receiver a regular argument. The value receiver v of method apps becomes argument v of type vertex. The pointer receiver v of method scale2 becomes argument v of type pointer to vertex. Then when you call function scale2 on the vertex instance v defined in the main function, you need to pass the reference of v, denoted by %v as argument. As an exercise, you should figure out how to rewrite method scale1 as a regular function and then how to call the function scale1. We have known that any method can be rewritten as a regular function by making the receiver a regular argument. But there's a difference between how the method and the equivalent function without receivers are invoked. In the case of pointer receivers, functions with a pointer argument must take a pointer, while methods with pointer receivers take either a value or a pointer as the receiver when they are called. For example, consider the method scale with a pointer receiver v of type pointer to vertex. This method is rewritten as a function scale func by replacing the pointer receiver v with the first argument, which is of type pointer to vertex. And in another function, let's define a vertex instant v. Then when you call scale func passing v as the first argument, it will cause a compile error because the first argument of scale func must be a pointer. So it must take % of v instead of v. But the method scale can be called on the value v as in v dot scale of 5 because this call is interpreted as % of v dot scale of 5. The method scale can also be called on a pointer, such as a pointer p, which equals % v. In case of value receivers, methods with value receivers also take either a value or a pointer as the receiver when called. But the equivalent function that takes a value argument must take a value of that specific type. For example, consider the method apps with the value receiver v of type vertex. This method is rewritten as function apps func with vertex v as a value argument. And in another function, we also define a variable v of type vertex. Then when you call apps func, passing variable v as argument is okay. But passing ampersand v, which is a pointer, as argument to f's func, will result in a compile error. However, you can call the f's method on both the value v and the pointer to v, as in p.f's, where a pointer p equals ampersand v. Here the expression p.f's is actually interpreted as star p.f's. Recall that star p is the value that the pointer p points to. We have learned the differences between value receivers and pointer receivers. Which one should we choose? There are two reasons to use a pointer receiver. The first is so that the method can modify the value that its receiver points to, as in the method scale here. The second is to avoid copying the value on each method call. This can be more efficient if the receiver is a large struct, for example. In general, all methods on a given type should have either value or pointer receivers, but not a mixture of both. In this example, both methods scale and f's are with receiver type pointer to vertex, even though the f's method doesn't need to modify its receiver. Note that this is just a recommendation for programming style. It's not a syntactical requirement. So of course, you can have a mix of both methods with value receivers and methods with pointer receivers on a given type. That's the end of the video. Thank you for watching. After watching this video, you have learned how to define methods and how to use methods in Golang. Hope to see you again in the next video, which cover part 2 about interfaces.